enterprise plus. Okay, here. So normally in a working environment, you just go click this add button. And no, we cannot add it. I need to type it. Let's try 542CS Y 3D0 D8 9. Okay, what did it say? Cannot adding the following key expired because this key is from almost 2-3 years old, so they don't allow me to add it. Let's try a new key. 3 and Y. So this is normally education key. They give you 1 year to use it. After that, the key will be expired. When you go enterprise, normally it's kind of the lifetime key. So you put it, you have a lifetime for it. Yeah, okay. See, this one has an expired date, and this one is 2022 August 30. So I can put license 1, or I can say ESXi if I want to make it a little bit different. And on the bottom, you can see this one is for enterprise vSphere 6 Enterprise Plus. Use like yesterday we said, this one license support 8 CPUs. So if you have a bigger group like 4 server, each server has sorry, if I have 4 server, each server has 2 CPU, this license is right for me. If I have a 8 server, each server has 2 CPU, I need 2 of these license. Okay. Go. Okay, so this is one key for your ESXi, which is you have 2 ESXi, 01, 02. I'm going to add a second key, which is vCenter. Okay, this is a key here. And match. Because I cannot copy paste. Normally, if this is your working computer, you can always copy paste this key. And you can always copy paste and mix the key. For example, I have one key for vCenter, one key for ESXi, one key for different products. I can just copy everything to this box. And this vCenter license server will try to help me organize. And you pop up say you have multiple keys, please rename them. And you're going to say copy one key, enable, copy one key, and another key enable. And vCenter. And on the bottom, you also see this vCenter server 6, and this key is a standard key. So if you remember, vCenter standard means the top key, and for ESXi standard means the cheapest or the less feature key. Okay, and here, instead of we say CPU for vCenter, we say instance. Okay, we have this one support 2 instance. Means this one key, you can have 2 vCenter running together. Go finish. So the first step is you adding this key to the system, and you should the next step is you sign this key to your product. And let's see, we should go here, go host. I see we don't have any host yet, so that's why we say okay. First job, we should go this folder which we call the host and cluster. And let's see if we should open, we should go and build a one data center here. You right click, you say, I'm going to build a new data center. and you go name this data center. If I follow the lab manual, they say training. Okay, so now we have a kind of data center. Actually, this one is kind of the folder here. Okay, so we name it as training. So for VMware, one thing I really like is this figure or this picture or this diagram. If I'm on very top, which is VCVA01, means that this is your vCenter. And actually, this is we. We are sitting here, have our own laptop, and we go through the network, config one vCenter here. So vCenter's job is going to manage all the PC or the ESXi behind it. Okay, so if I go click training, and you see we are focusing on all this ESXi host and on top all the VMs. Okay, open that. See, empty here because we didn't add any host yet. Okay, so we're going to add the host. You can go right click, and you can say add host. There are two ways you can add it. One way you add with IP address, and second way you add with domain name. Okay, normally here we can add domain name esxi01.v class local. Next, and username is always, if it's not that fancy, it's always root. MELI123. And they will say, please double check the key SHA1 key, make sure this is what you want. Okay, say yes. And host summary said, inside this host, I have one virtual machine. Yes, I built one virtual machine there. So I say, yes, that's right. And this one is assigned a license. Now, because they're running on evaluation license, and your vCenter has a license key or database. Now you say, I only have one key here, but you can have multiple key later. You will say, okay, I want to use one of this key. If I go click here, and just check this CPU number. If I move the key, say I want to use this production key, go here, and you say the usage is 2 CPUs. Okay, so if you from the previous lab, you collect some data from your ESXi host, you will see this ESXi has 2 CPU. Okay, so that's why we use 2 CPU here. And this is lockdown mode. You say I don't want any lockdown mode. Location, because we only have one data center which called training, so we say okay, it will be under the training. And you say finish. Okay. And on the bottom, this is your recent task. You can keep monitoring if okay, evaluation license assign vCenter. Okay, they pop up a warning said license not available to perform this operation because my vCenter is has an expired license. So what I want to say is it's not about this VMware, it's about everything. When you configure your router, configure your switch, or do any lab, I see most of the student is say, please help. I cannot ping from router 1 to router 4. So normally I will ask students, just have a look at your screen because your router is trying to tell you something wrong, right? They start pop up some message. I say, first thing you should try to read it. You don't say, oh, I see an error message, something wrong, I should ask help. It's not like this way if you go to the company, right? Your first thing you troubleshoot by yourself, and the troubleshooting first step, read the error message. Let's see what the message try to tell you. If you don't want to see the message, you just say, oh, something wrong, I should call someone help. It's not like this way, okay? So that message said is we cannot add this ESXi because vCenter have some licensing issue, right? So we go back to licensing administration, license. Host, because we didn't add any host, right? This kind of chicken egg chicken, because we cannot add hosts. So here is all empty because empty you cannot add hosts, but everything cost is because it's a vCenter server. You say this one is one instance, but the license expired. Okay, so we need to assign the license. So click that button. They will say, do you want to switch from evaluation license to the license we just added? We say, yes, we want to go this way. Okay, now we have a good license. And I see we have some other. Okay, you see, no, I like the VMware sometimes at the very beginning page, they will give you a brief talk about what is this, this is a service do, or what is this task will help you to retrieve. So this is all about license management, right? So it's like this. Okay, now we have a good license on vCenter. We go back. See, sometimes if you lost here, you say, oh, I don't know how to get it back. This key, the home button is always good. Just if you're not sure, go click home button and you can go home. That's always the first page. So we try to add a host. So we go host here, try again, add a host. Yes, xi01.v class.local root. Same thing here. We have one VM. Oh, sorry, that's a key. We should give a new license. No lockdown mode under the training database. Finish. Okay, see the recent taskbar, they will perform this task. And if something really getting wrong, you have the red arrow. And if everything okay, they will say completed. Okay, they are 80%. Okay, I'm going to add a second one. Oh, the first one is coming. See, first one coming with some error message, right? Just install, ignore. Yes. So let's see summary. We have the message that expired. This one we fix that. The new one, same issue. Okay. So let's add a second one here. Add host esxi02.v class.local. Let's say answer yesterday, someone's question said, can I use IP address here? Yes, you can use IP address. And they said, why you use a domain name, not the IP address? For small company, that's totally fine, use IP. Like we use IP because I don't trust DNS. Like the Google, like the Facebook issue is everything rely on the DNS server and they only get 4 DNS server. If the 4th DNS server down, the entire Facebook company down, right? They centralize everything. For us, we have only, if we build, we will only build one DNS server. If that DNS server down, all the service, all the student lab, and nobody can do it. So that's why I say, okay, better use IP. But what's the benefit use a host name here is because we, in a big company, you have the layers, right? If I have the Python team or automation team try to write some code to do the automation for ESXi or what any server, they don't like to put destination IP address because as a network team or server team, they may replace this server with other server, put another IP address. And in that case, you need to ask the programming team, say, okay, we just upgrade the server, please upgrade your IP address. No, they don't like this way. So normally they will put dedicated name, say ESXi02, and I don't care this one point to any IP address, any network. I just say this is your second server. As a network team and as your server team, you can replace this server, you can upgrade the server, change the IP address, but this one is always bound with this domain name. Okay, so it's same idea as your TCP/IP class. You will see between each layer, they just pass certain parameter to the next layer. And each layer, they're working as their own team. They don't need to talk much to the other team. So that's why in the big data center, they always use this domain name. Okay, in that case, when you design the DNS server, you need to be very careful. If something wrong, that will be a disaster there. Okay, second one. In second one, I also build a VM. Okay, so same VM here. You remember license for ESXi? We already signed this to ESXi01, so already 2 CPU are used. So we sign the second one, now it's become 4 CPUs. Okay, finish. If you are normally when you assign the ESXi to the vCenter, from this moment, everything, all the control, everything is happening in the vCenter. Until vCenter crash, you need to go back to the ESXi to do something. Otherwise, everything will be happening in the vCenter. Okay, so I have 2 hosts and 2 VM there. Next one. So next one is talking about how to configure the NTP client. And remember, NTP is happening on the ESXi layer. So when you configure ESXi, you should click one of these ESXi hosts. And let's go manage. And when you configure this, when you go to ESXi host and go to manage, all this configuration is point to this ESXi host, not to the vCenter. Okay, so let's check here. Okay, see after the training data center, this is your cluster or data center. Now if I go click this ESXi, and you see I'm now focusing on only one server, which is this host. We say this is a host. Here we go manage. We go time config, and by default they say NTP client disable, NTP server and stop. So you can go edit. You say use network. You say start stop now manually. You say start stop with a host, and you can put some NTP server. Let's say I put this. Okay, and wait. To this guy. Edit. Sorry. It's start stop with host and put pool.ntp.org. And before you click OK, make sure you click this star. After you put all the parameters, you say star service and click OK. And now it says enable running. Let's go back. Just give me a second. Sorry about that. Okay, so back here and enable stop. You see here, it says the NTP server stopped because we didn't click that button. So click here. Now service run. Click OK. Okay, so now both NTP clients running. So this is your lab 4. Let's see lab 5. Yeah, no, lab 5 is okay. See next one. After that is ask you to build some folders. So what's happening here is the first tab is your cluster host, and you see the entire stuff like the ESXi host, VM inside. Second one is just VM, right? They collect all the VM and they put it here. So normally you can build some folder based on location, both on the task. You can build some folder. You can right click, you can go new folder, and you have a say, do you want a host cluster folder? For example, you can group some ESXi host server as Intel AMD CPU based. Right, you can have a network folder, put different network in different folder. Storage folder, you can say production storage, put a few storage in the production folder. And other storage, you say training, and you put on the amount training. Last one is VM and template. You can group the VMs, say student 6111 lab, 6112 lab, something like that. Okay, so the next one is ask you build some folders. Okay. Yep. So this is almost cover everything we talked yesterday. Okay. Let me go back here. Okay. From that, we covered almost everything from yesterday. So now let's start a new topic. So this topic has two big subtopic here. And the first topic is we call the standard switch. Normally we say it's a vSphere or ESXi standard switch. So what's that do? Okay. Type of the virtual switch connections. So our virtual switch has a specific connection type. This is number one. We say this is a virtual machine port groups, which this one is facing to VM. Whatever VM you build, firewall VM, any VM, you are going to use this called the port groups. Second big one is called the VM kernel port. So VM kernel port is facing to ESXi. I mean, face to itself. So this one is for this one is for IP storage. If you have iSCSI, all this storage, you need to have this interface. High availability means if one VM down, this same VM, no, sorry, if the ESXi host down, this VM will be active on the other ESXi host, which we call the high availability. vMotion means you manually or automatically say, please move this VM from one location to other location or one host to other host, which is vMotion. And vMotion migration. Fault tolerance is a similar topic as high availability. High availability is that if you have two hosts, two ESXi hosts, if I have a VM here, and if this ESXi host down, and this VM will be active or restart on the other ESXi host, which may take a few minutes because when you restart your Windows, it still take some minutes or seconds, right? So this is called high availability. So what is fault tolerance is if I have my VM here, I will have a dedicated channel and I will duplicate another identical VM here. So at the same time, both VM keep the identical, means if this, I have a monitor here, if I have my mouse cursor move at this VM, even this mouse cursor will follow. Okay, means 100% identical. If this one down, this one will take the job in you can say immediately. You won't lose any data. So that's why I said the fault tolerance will be the very, very high level secured way. But the issue is if you run one VM here, you took two VMs resources from the entire data center, right? Because you have two identical one run at the same time. Okay, so this one also need to have a dedicated VM kernel port. vSAN is technology based on VM, same, you need to have a dedicated port. Replication, also this for ESXi management network. Okay, so let's have a look at this. So if this is your virtual switch, by default, when you build your ESXi, you have one virtual switch, okay, which we said switch number one. This uplink is your physical server's physical port. And you can plug this RJ45 cable to this port. It's not say you must have four. Some server have two. If you build a computer, gaming computer as your server, you may only have one here. Okay. But if you have a server, sometimes they have two. And if you have a lobby high-end server, they come with four. And if you have a dedicated, you say, I want to run another port, you can have a NIC card. A NIC card will provide you another four or whatever port you need. Okay. So uplink port is facing to the physical world, which means you can connect to a physical switch and connect to a physical router, connect to the outside world, or maybe the firewall outside world. Okay. So when this data sends through this physical cable go inside your ESXi or the ESXi host, this is all the virtual port. Okay, this is all the virtual port. First thing we said, this is your virtual machine port groups. And if you remember, I said this is all facing to VM. So you can have different VM point to different port groups, like the production, test development, and the DMZ. Okay. This all facing to VM. And this two port we called is facing to itself, ESXi. So when you first from your first thing when you log into your ESXi, you know, the GUI, and you have host, a virtual machine, you know, network, that GUI is from this interface. Okay, so that's why yesterday one of the students showed me he has a VM environment somewhere, and he has IP address ending with 151. You will see actually this IP is signed to this management interface, which is give you a destination to log into the entire environment to manage this port. You know, maybe you want to delete it or you want to add one port. So everything happen from this interface. Okay. And your VM definitely has some different IP here. Your VM may have 152 and other VM may have 64, whatever. I'm talking through here, through different port to the outside. But if you try to manage, or if you vCenter try to manage your ESXi, the management port is the only destination you have. Okay. But here they put another port, say this is your vSphere vMotion. So why they have second port is you actually don't need to have this port. One port is more than enough. They can do management, vMotion, high availability, HA, fault tolerance, FT. But the issue is this port has a dedicated bandwidth, 1 gig, virtual one. You don't want to run all these tasks through 1 gig interface, right? That's why they want to say, oh, I want to move this vMotion, which is costs a lot of bandwidth, to a dedicated port, right? This will be vMotion. And you may want to use different dedicated port for this fault tolerance, high availability, even you have a for iSCSI, which is storage. Okay. So why sharing the port is an issue is first thing, you get more port, you have more bandwidth. And sharing the port, another issue is the most critical task or job is management. If you lost the management, you lost everything. You cannot control it, you cannot manage it. You cannot recover the server. That's why we want to have a dedicated port just for management.
Excuse me,
Yeah, go ahead.
sorry. Can we team the uplink ports together, like
Yeah.
um, I mean to improve the bandwidth?
Let's have a look. Good question here. Let's see. vCenter switch features. Okay, normally they have a long feature table. You can just go and have a look by yourself. But I remember is if you have a standard switch, you cannot do a group, you cannot do port teaming. But if you have a distributed switch, you can do the port teaming here. Okay, that's what I remember. But you need to, if you get a chance, go and Google it. You may find a detailed document. So why I say that is because standard switch count for sorry, okay. Even you don't have your vCenter, if I don't have my vCenter from the ESXi, I have my standard virtual switch. Okay, I have my standard virtual switch here. And I only paid less money for this license, and they come with this switch feature for free. So in that case, if it's free, they don't want to give you much feature, right? Until you say I want to have vCenter. If you have vCenter, you're allowed to use a distributed virtual switch. And because we paid a lot of money for the vCenter and you pay the extra feature fee for the switch, now you can have your the port teaming working. It's not about the technology. In the technology, yes, standard switch should support it. It's nothing hard. But from the money side, company will say, if you want that feature, teaming two port together, you'd better pay me more money. That's why they have a different license, right? Okay.
Thank you.
You're welcome. So that's why I said, if you buy anything for your company, first thing goes through the feature list, make sure all the feature you want is in the list. Okay, next one. Okay, you may say, oh, looks like we have teaming here in a standard switch. What's happening here is, they say more than one network can coexist in the same virtual switch, all network can. So this is telling you is you have the same goal from, let's say you have the same task from A to B, but how to reach from A to B is you have different way to dealing with it. The first one is as a system administrator, you can put everything in one big switch. You can start manage this vMotion, or maybe mapping something like this way. Let's it dedicated to some port. It's okay to run this way, but not best, right? Because you see lots of relationship or map between virtual port to the physical port, and everything is in one switch. They try to cross talk to each other. That's why people say, can we just isolate the traffic? So in the production, this is become more popular. Right? At the beginning, you have this one virtual switch. You have your management interface, and you have one or two port bound with this virtual switch. And you may say, oh, looks like this is a teaming. If I remember correctly, this one is active backup. Let's say which one is active, which one is backup. And if I remember, if you put both active, they only support the basic feature of teaming, not that dynamic one. Okay, so for that detailed one, you need to go through the feature list. Okay, anyway, let's keep it basic. This one is facing to the outside world. And because it's important, right? Management is important. Normally you can put two physical interface to go to switch and to keep high availability, right? You can say active backup. And later you say, okay, I want to build a virtual machine here. And I have a dedicated switch for the production virtual machine. And I have a dedicated interface to go different port of the switch and go to different. Same here. This is best design because first thing you see, they have all these two ports back up each other and give you a more reliable network access. But the issue here is if we count the bottom number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10 NIC. And in the real world, you can never find 10 NIC interface in one physical server. You can, sorry, you can build a server with 10 NIC, but in the production, nobody will do that. Why you say we cannot do that is because first thing, each interface costs you money, right? Their production, their enterprise level NIC card, which costs you thousands of dollars of this NIC card. First thing, you add more port, you add more money. The second thing is when you have any physical cable, you have some RJ45 or SFP port, you have a chance have some damage in the cable, damage in the port, you have more physical stuff, you get more chance to get some error here. So that's why if you go to the the big data center, for the one box, they only run two network cable. Sometimes maybe three, but they try to two. And they may run another extra small cable. This one is RJ45, which is for the dedicated management or backup for the management. And this two cable normally is 10 GB, basic 10G. So if it's 10G, and if this is 1G, one cable, you can grouping all these bandwidths together, right? And most of them even go 40 gig, 100 gig, and now even you have 200 gig, okay? But basic one, not everybody is going 10 gig. And you will see some bigger data center, they use 40 gig, and 40 gig point to one server. In that case, 40 gig is more than enough, right? So old one, yes, we have 1 gig, we have lots of 1 gig. So the issue is you have more cable, you get more chance to have some issue with physical port. Okay, next one. The virtual network support this type of the virtual switch. Like I said, you have a standard switches and a distributed switches. Standard switch said the virtual switch configuration for a single host. Like I said, without vCenter, if I have ESXi, I have this standard switch. Okay, standard virtual switch. If I have second ESXi, they come with standard switch. So what is a distributed switch here? So this distributed switch said a virtual switch that provide a consistent network configuration for virtual machines as they migrate across multi-host. Okay, so the concept is this way. I I build two ESXi. And instead of I have a switch here, now I can have one switch, virtual switch across the entire data center, which I say distribute switch. Okay, and remember distribute switch is based on vCenter. If you have vCenter, you can have this feature. If you don't have vCenter, you cannot use distribute switch. Let's see if they mention. Okay, they mentioned something. Okay, let's keep going. Next one. So a standard switch provides a connection for virtual machine to communicate with one other, whether they are on the same host or on different host. So let's have a look here. First thing you see, we have VLAN tag here. Okay, and let's start from top to bottom. The first thing we have 3 VM, and we have IP storage and the management network, and this both based on ESXi kernel, because ESXi kernel is taking care of this traffic. And when they have different traffic, they send to a different switch, like the previous one. Some switch is dedicated for management. This one is dedicated for storage. And when they send out, they have different color. And the color code means VLAN. You go here. And from this interface, send outside, we have the VLAN tag. We say IP storage VLAN is 103 and the management VLAN is 104. So we have one port or one switch dedicated. This one is one port dedicated for management. Another port is dedicated for these VMs. Okay, so VM1, you have maybe this is a test. Okay, VLAN 101. So you send it to the dedicated switch for this VM, send it out, and you go add a VLAN tag and send out. And the VM2 send to this switch, and you find this switch don't have any outgoing interface. That means this switch is dedicated for the internal traffic. Means if one VM want to talk to another VM, you use something like this. So this switch don't have outgoing interface. Everything is facing to the VM. So in that case, VM2 is only talking to VM3, or VM3 can talk to VM2. So this is between these two VM. So at the same time, VM3 also has kind of the internet interface which provides a service through one switch and to the outside. But from here, oh sorry, this is a port, this is a switch. And from here, you see they have two cable going to one, going to the one switch. So in that case, you have some redundancy here. If I lost one cable, this cable will take care of the job. Or if we lost this side, and this side will take care of the job. Okay. So from the bottom, you see we start use VLAN to isolate the traffic, not the physical cable. So building the standard switch configuration, and this is, we can have a look here. Yes. Okay. So we can go to host. This is first host. We go networking. So by default, you will have this kind of the switch. We have one switch interface which facing to the outside world, and you see the name is called VMNIC 0. And if we go, back to here, clear this part. For ESX01, we have a 4 interface going outside. The bottom one has a number, VMNIC 1, VMNIC 3. From top, I didn't mention the number, but to the management, this is VMNIC 0. And this is VMNIC 2, I believe. Let's see. Okay, so VM NIC 0, if we go back here, VM NIC 0 is facing to my management interface. So that means I have 3 extra physical interface. I didn't use it yet. Okay, so that's one interface, physical interface facing to the outside world. And after this circle is your virtual switch, and they go talk to the inside. First thing I have is which we call the VM kernel port, and this is my management network. The IP address is 10.51. So if we check, if we say 10.51 is this guy's IP. So if you remember when we logged in, we log into this IP, right? We put 172.20.10.51. So this one provide all the management here. You may say, what is the second one called VM network? So by default, if you have any VM you built, so by default, they are also connected to your management network. So because we built that Windows, and we didn't move that Windows from management to dedicated production, so that Windows is still connected to my management network. Okay, so this is a standard switch. Same here, if you go second host, it's the same topology here. Okay, next one. Where are we? Here. Okay. Yeah. So this is the example here. So remember, this one looks like a NIC card. This is facing to the outside world, and on the other side, this all facing to the VM side. VM kernel, ESXi, or virtual machine. Okay. And from the top, you can have multiple switches, and you can but normally start with 0, 1, and you can have DVS. DVS means distributed virtual switch. Okay, so you manage all the switch from network from this tab. Okay, about VLANs. So you learn this VLAN from 6112 physical. Okay, so first thing they said, ESXi support 802.1q VLAN. If you learn this from 6112, you know, Cisco, by all Cisco, they have two encapsulation. One is .1q. Normally, when you say encapsulation, you don't say the full name, it's too long. Sometimes they say is .1q, especially when you configure the switch or VLAN, you say encapsulation .1q. Okay, so we normally say, oh, my VLAN encapsulation is .1q. For the old Cisco, they have ISL, but not much guy use it, so it's all gone. So only one option left for everybody is .1q protocol. So this is also with a VLAN. You have VLAN traffic. The traffic will be tagging. Okay. So what they say? Virtual switch tagging is one of the tagging policies supported. Package from virtual machine are tagged as the existing virtual machine and tag on return. This is the same thing they are talking about inside the 6112. Provide VLAN support by giving a port group. Okay, let's talk about here. Let me see. So I know someone just finished physical. Is Annie told you this physical lab, right? So how about other groups? How about other groups who's just finished? Okay, other groups is like this. You just finished 6111. I'm not sure. Afan mentioned the VLAN. Do you learn VLAN tag?
Sir, we did the VLAN lab.
6111, right?
Yes, sir.
Okay. Okay, let's try this again. So, like I said, you may already know what is VLAN tagging, and I just want to put more detail here. It's not about this VMware. It's about your basic switching knowledge. Okay, just double check if you know everything, or maybe you are not 100% sure what's happening here. Okay. Let's see these sentences. Package from virtual machine are tagged as they exist the virtual switch. So that means,
Sir, I have a question
go
here.
ahead.
So we will be doing this lab that like you will be assigning VMs in different VLANs, like IP addresses on different VMs on which is associated to different VLANs, and we will be able to like connecting the EXX physical ports to the VTP ports of the switch. We are doing this, like the physical
No,
connection. How? Okay.
no, you are not going to touch any physical connection or physical device here. Everything is virtual. Okay, so, but like I said, the concept is most important. Play with the cable is another job, but concept is more than important. Why I want to, okay, let's talk this way. Why I want to spend more time on the VLAN side is not about this VM. Okay, that's why I moved to this side. It's about your job interview. Okay, I'm not sure how good you already be in the VLAN side, but in my opinion, if you after you finish the course, you're looking for the job, and if you have interview, if they have question about switching, you definitely will facing the VLAN question there. Okay, you're definitely facing the VLAN question. Let's start with the basic one. Okay, if I have a switch, and if I have a one PC here, I have a one PC here, and if I say from this switch, this is VLAN 10, from here, this is VLAN 10. From top, the IP address will be 10.0.0.1, 10.0.0.2. Question is that PC A can talk to PC B? Okay, the answer is yes. Why? Is because you say from layer 2, they are on the same VLAN. On the layer 3, they are on the same network, right? So they can talk to each other. But how they can talk to each other here? First thing, let's say A try to send the traffic to B. So what you already learned from intro and physical is forget about layer 2. Layer 3 will say I'm from the source, I'm source A. I'm going to send this traffic to destination B. This is IP, right? And with a MAC. What is with a MAC? MAC. And A will send it to the switch. Okay, first question is, in this cable, do we have VLAN tag? Okay, so any traffic flow inside this cable, do we have VLAN tag or no VLAN tag?
No VLAN tag, I believe.
Yeah, no VLAN tag. Okay, remember if I have access port, this is access port. So let's see, access port VLAN 10. You have an access port. Okay, let me make it bigger here. If I have a one port is access. And remember the boundary is this switch. Okay, anything facing to inside this switch, you have tag. Anything facing to the outside, you have no tag. Okay, if I have an interface that's a trunk, means inside and outside both has tag. Okay, so this is a VLAN tag. So first thing is we have access port. Access port said Okay, there's no tag here. No tag means I can send the regular IP traffic, MAC address, IP address, source destination to the switch. So when this package get through this port, so what's happening is because we say this is access port VLAN 10, you need to add a VLAN tag here. So after that, you have your VLAN tag. And you have your all this whatever traffic data here. And actually when they go in, they will send it out. Right? Like I said, when you send it out, inside this switch, you have your tag, but when you cross the boundary, which is your physical switch, this port will help you remove the tag, not remove here, I mean remove here. When you cross this boundary, they will remove the tag and only keep your source A, destination B IP address and send to your computer B. Okay, so this is a basic access port, right? When you send any traffic from outside to inside through access port, the traffic is from outside, no VLAN tag. Get inside of the switch, you have VLAN tag. If you have a traffic inside this switch with VLAN tag, and when this guy cross the boundary, which cross the physical port, if this is access port, this port will help you remove the VLAN tag, only send the traffic get out. Okay. So next one is trunk. Just close this. So we know the trunk interface. Normally I draw a trunk like this way, like a big pipe. Trunk is you can have multiple traffic with different VLAN tag, tag 10, tag 20, and all this traffic will pass through this boundary, means outside, inside switch, and keep the VLAN tag. Okay, tag 10, tag 20, and go through it and pass this way. This one we call the trunk. Okay. So if you're clear about this, I'm going to ask you one question, and hopefully someone can answer that. So this is an interview question. I have the same configuration. This is A, this is B. And this guy said, oh, no, that's this way. Computer A connect to a switch. Switch connect to another switch. This one connect to computer B. Okay, IP address will be 10.0.0.2/24. And this guy said, someone already configured this interface as access VLAN 10. And other guy said, I already configured this interface as access VLAN 20. And the interview question asks, say, if I want computer A talk to computer B, what should you do? And most cases they will ask you, what should I do about this interface and this interface? Let's say this is switch 1, this is switch 2. So how you are going to configure it? Let's say switch 1 interface switch 2.
VTP, as a VTP ports, we can configure it.
Not VTP. VTP is called virtual trunk protocol, right? It's about the negotiation. And now we don't need to do any negotiation here.
We have two ways to configure it. If we configure it as a trunk, we can switch 1 and the native VLAN or switch. So we can run it as access. The first switch access VLAN 20. That
Okay.
would be better.
Yeah, you have both options now. Yeah, that's good. Yes, like I said, in that case, if you know the answer, means you are really good at about VLAN tag now. Okay, what they said here is you have two options. Let's start with the basic option. Basic option is say you put access VLAN 10 and access VLAN 20 here. So what's happening here is if I send the traffic A to B, when I cross the boundary, they will add VLAN tag 10 and A to B. So when I send the same, this tagged traffic goes through this boundary, because if we understand is go from inside to outside, we remove the VLAN tag, the traffic back to A, B. And now we are going to cross the second boundary. And because this is access VLAN 20, so now we put VLAN tag 20 here, and we put AB. And same thing, if you go cross this boundary, you are going to move VLAN 20 because this access port 20. Okay, so this is A and B, and they reach to a destination. So this is oh, okay, yeah, sure, okay. So this is like a standard answer for this question. So next one, this guy said we can add this as a trunk, right? Trunk means allow multiple VLAN pass through it. But the issue is how to shifting this VLAN tag from VLAN 10 to VLAN 20. So that student answer said we can put the native VLAN 10, native VLAN 20. Okay, so when you go, when you finish, somehow already finished the intro, sorry, physical. So native VLAN means only one VLAN with the number, you can treat it as access. Means if I have a VLAN 10, when I go through this terminal, because I might say, I say native VLAN is 10, I'm going to remove that VLAN tag and put source destination here. And when I move out from this trunk interface, because we say native VLAN 20, I'm going to add a VLAN tag 20 on top. Okay. So this is about VLAN tagging. So if you are not 100% sure what I'm talking about, just try to go review the topic, because really for the job interview, for the switching, this is a question they will ask you, right? If you don't know VLAN, they don't need to ask more feature about VLAN switching technology, right? If you don't understand VLAN, it's like you don't understand spanning tree. Maybe they don't want to ask you more questions. Okay, switching VLAN is it's a very, very basic one, because even you go to small company, the smaller company may not have router, may not do routing, may not do fancy routing protocol. But trust me, all the company has VLAN. Doesn't matter, small company, medium company, large company. Almost everybody run VLAN switching. May not run routing, but switching will be there. And foundation of switching, VLAN. Okay, VLAN tag. Okay. So back to here, they said this one is a package from the virtual machine tagged as the, what's happening is for this virtual machine, let's say this is my Windows. When you say by default configuration, your Windows only talking outside with IP address. So there's no VLAN tag. And you send through this virtual switch. So virtual switch is as your physical switch. So this is one virtual port, which like your physical port. If you remember, we said when you cross the boundary between inside and outside this switch, there's no tag. And when you cross, you send in, you suddenly, you immediately put the VLAN tag 105 to this traffic. Now we have 105. And if the outside is a trunk port means a big pipe. This VLAN 105 will keep and cross this trunk port, because if it's trunk, they allow you pass with your VLAN tag. And you can send it outside. Send to the switch with VLAN tag 105. The same here, you have another VLAN, VM, and this is no tag. When you cross this boundary, you have tag 106. And you will send the same traffic with different VLAN tag to the outside, means to the physical switch. Okay. So that's why it's a package from virtual machine. Let's try to read this again. Package from virtual machine are tagged as they exist. Virtual switch means when they are leaving this virtual switch, they will keep the VLAN tag here. And this is second one is VLAN package are untagged. This is this way. Untagged as they return to the virtual machine. So when you send the traffic back from the internet to the virtual machine, when they cross this boundary, if this opposite way, they will remove the VLAN tag. If it's from inside to outside, they will remove the VLAN tag and keep no tag here. And just remember outside, if it's access, outside zone is no tag zone. Inside is always have a tag, okay? So that means from inside to outside is tag to no tag. If you go from outside to inside, it's no tag to tag. Here is a ESXi provide VLAN support by giving a port group a VLAN ID. If you remember, the port group is kind of the one big interface facing to the VM. So when you configure or when you give the name, you can also mention the VLAN. You say, I want this one belong to 105 or 106. Okay, so, or you want to say no tag means none, 0. You have another option said all tag. All means from 1 to 4094 means become a trunk port. Trunk port is like this way. If I have here virtual switch, and I have another kind of the virtual machine which this guy support trunk. This is already a trunk. So you can have a dedicated trunk port on your switch. That means anything I send through this VM. So this VM actually will add a tag here, tag. You'll go through this trunk port and send to another trunk port to the outside. Okay, so that's by how you're going to configure this VLAN ID. You have a single number. This one will be access port. If you say none, this is VLAN by default is no tag. And if it's all, means this interface become a trunk interface. Okay, let's finish this one and have a break. Okay, next one is called network adapter properties. Physical network can become a bottleneck for network traffic if the adapter speed don't match application's requirement. What that means is, see here, when we talk about VM NIC, anything about the VM NIC, I'm talking about the physical interface facing to outside world. And from this picture, we see all this physical interface is 1 gig, right? It's 1 gig. And if you see more, this is Intel 82545 EM gig Ethernet controller, copper. Copper means RJ45 in that case. Okay, when you say copper, that's RJ45. And this one only have 4 network card, so 4 network interface, and which one, all of them are 1 gig. But it's not stop you said if I have a virtual switch and I have a port group and this one connect to my virtual machine. And if I have I can have a 10 GB port here. Okay, if I have a 10 GB virtual port facing to your virtual machine and you have only 1 GB facing to the outside world, so your physical adapter can become a bottleneck. That's this sentence set, okay? In that case, 2 solutions. One solution is to upgrade your physical become 10 gig, which costs you lots of money. Other solution is change this virtual adapter to 1 gig and to see if your customer happy with that or not. If your customer happy with 1 gig, you have a safe boundary now. Okay. So this is about physical adapter speed and the virtual adapter speed. Okay, make sure you can control them or manage them. Okay, so let's have a break. It's 10:26. We will be back on 10:40. Okay, let's have some break. 14 minutes break and come back on the 10:40.
Okay, Professor.
And like I said, if you are here and you didn't send me your B number, and please send me your B number so I can do attendance here. Okay, because I know some new student joined during the talk. Okay, just send me the B number so I can add you to the attendance sheet. Thank you. Okay, it's 10:40, so let's keep going here. So before I start this topic, any question about standard switch? Looks like we're okay here. Let me stop sharing this. Okay, looks like we are okay, no question there. So let me show you something. So I have one small NUC which from, this is an old version, like this i5, 5th generation, but just want to show you the size, right? This is your NUC. So that's something I prefer to, as a student, you can build a small server under this tiny size. So that means when you're traveling, you can just easily put this in your luggage and you travel with this small box. Okay, and you can connect a big monitor when you have your location, you can connect a big monitor TV to enjoy some higher performance, and it's much cheaper than the gaming computer. And I even have some very old technology. This is also Intel manufactured. It's like a pen drive, right? Something like this. So this one is called Intel computer stick. Okay, so this is a computer this size. Okay, even smaller than that. So the design is, this is HDMI port, so you can just go directly plug into the big monitor, and you can run some. This one run basic Windows. You can run basic Word or browsing stuff. And just want to show you the size. Computer size can be so small. And I remember,
It
yeah,
comes with an Atom processor, if I'm not wrong.
yeah. And I remember this one is come with Atom. And Intel also have one called a computer card. It's like your credit card size. You know, it's like a credit card size. And that one comes with even i5 CPU, I believe, built in. But 2 years ago, they stopped that project. No more of that computing card. So the idea is for that computing card, like your credit card, you have your personal computing card, which is a personal computer. And in your office, they have a terminal. So you just plug this card to the terminal. You can use monitor, keyboard, mouse. And they have the laptop. Also, you can plug this to the laptop. You can have your personal laptop. That's some very good idea, but Intel stopped that project. Okay, so just something extra I'll share with you. Let me see if I can find the computing card. They call the compute card. Sorry. Yep. Okay. So this is compute card. It's like your credit card size. Okay. Sometimes they have the dock. You can plug this card to the dock, and after that you have a monitor and the computer. Sorry, the keyboard, mouse, and something like this laptop. You can plug this one, and you can have your laptop. So yeah, this is called the compute card. This is laptop. You can plug it to it. Okay. So there's some good idea, but Intel just stopped it a few years ago. Okay. Okay, that one. Okay, back to our topic. Let me put a chat window here. Okay. Okay, so next part is talking about configuring standard switch policies. Okay. Policies set on a standard switch level apply to all of the port groups on the standard switch. Okay. What kind of the policy we are looking for is we can have a security policy, traffic shipping policy, and link teaming and forward policy. That's one of the students asked before. So now we can find the answer. Policy are defined at this level. So you can, for the standard switch level, you can say default policy are for all ports on the standard switch. So how to understand these sentences is, if I build, under the ESXi, I can have one virtual standard switch, or I can have second virtual standard switch. And this sentence is that if I put policy to one of these switch, if this is my switch with port facing to the VM, kernel, physical port to the outside. When I put policy, I put policy to cover the entire switch. Okay, so that's the sentence there. Default policies on the standard switch means policy will apply to the entire standard switch. How about distributed switch? Sorry. Another level is port group level. If you don't want to apply the policy to cover the entire switch, you can say, okay, I just want to put some policy under certain port groups and some other policy based on other port groups. Okay. So they say this one is port group level. Policies are defined at this level override the default policy set at the standard switch level. What's that mean? This is kind of, we'll go the security lab, the ACL override another ACL. It said if I have a big policy, let's say this big policy said this interface only allow 10 meg per second traffic. Means no, they said all this interface from the global policy, all the interface will be 10 meg per pod. And you can define another policy say that only for this interface, I want this run 100 meg. So this 100 meg, the detail policy will override this global policy. That means the rest will be 10, and this one will be 100. Okay, this is what they say here. Next one is called the configuring security policy. We have a 3 topic here. So administrator can define security policy at both standard switch level and the port group level. When we talk about standard switch level, you should have the image, means policy covers the entire virtual switch. If you say enable, all this entire physical entire virtual switch will be enable this feature. Second level is port group level. For example, you want certain virtual group, virtual switch port group have this feature, security or no security, you can just go port level and turn it on or off. They have a three security policies here. The first one called the promiscuous mode, second one called MAC address change, and the last one called the forge transmit. And let's talk about them one by one. First one is called the promiscuous mode. Allow a virtual switch or port group to present all traffic regardless of the destination. Okay, so what's that mean? First thing, the question is, how many of you guys know Wireshark? The Wireshark, and how many of you guys already use Wireshark or know Wireshark?
Sir, I have used Wireshark.
Okay,
No, I've
good.
used, sir.
Good, very good. So as a, as a network guy, this is the basic tool. Everybody should have it. So if you don't have it, you can install it to your computer and play with it. Okay, Wireshark. What Wireshark do? Wireshark will capture all the network traffic and send to Wireshark and let you analyze source destination, MAC, IP, layers 3, 4, 5 to 7. Why I'm saying this? Let me have a because this is about this premix queue mode. So first question back to here is that what's the difference between switch and the hub? Okay, if I have a 3 PC here, connect to a hub. Oh, I have a same topology, 3 PC connect to a switch. Question is what's the difference between switch and hub? I know now you won't see hub, everything is switch, right? But long time ago, we have a lot of hub. Why? It's because hub is much cheaper than switch, right? Switch, a long time ago, they cost you a lot of money. Let's say this is A, this is B, this is C. Okay, so you can just type your answer, say yes or no, say I know what's the difference between switch and hub, or I'm not sure what is hub, or not clear. So in that case, I don't know how many of you guys know this concept here. Yeah, someone know it. Okay, okay, good. Okay, for someone know what's the difference between switch and hub, now the question back here. If I run Wireshark on the computer C, and if I send the traffic between A and B, can I capture the traffic between A and B in a hub? Or can I capture the same traffic in this computer, which under the switch?
Sir, in the case of hub, we can capture it since C receives the packet. And in the case of switch, we cannot because C is not receiving the packet.
Yes, that's right. This is answer for that kind of question. So for the hub, what hub do? Hub is say, if I send the traffic, hub will broadcast to everybody, whatever port I have. One traffic in, I broadcast. Another traffic in, I broadcast. That means A talk to B will send the traffic to C. C will receive the same copy of the traffic. And between switch, because switch based on MAC address source destination, A send the traffic to B, A will send to the switch. Switch checks the MAC table or MAC table. So okay, your destination will be this port and only send to B. C won't receive anything. Okay. So in that case, if you run Wireshark, the basic concept is say, if you under switch, if you don't configure switch, computer C cannot get anything between A and B because switch didn't send you a traffic. Okay, now let's back to hub. Anyway, hub say I don't care. There's no security level, no security config. I will broadcast everything. So between A and B, let's say A send the traffic to B, and the hub will give a broadcast and send the one copy to computer C. Now, next question is if IP address, if A's IP is 10.0.0, sorry, 10.0.01, this is 10.0.0.2/24. So on the computer C, I'm running Wireshark on one of these, on one interface. My question is, if I want to capture the traffic between A and B, do I need to have an IP here, like 10.0.0.3? Do I need an IP on my computer C, or I don't need to have any IP for use Wireshark?
I believe it should have.
You should have.
Yeah, I believe because it won't. It won't. Otherwise, it won't pass the traffic to the software.
Yes. Okay. That's one answer. Said yes, we should have IP, and and he also explained the reason is said because if we know TCP/IP layer, right? You know, from layer, they will check your layer 2 MAC layer. If the traffic is for you, you pass to the IP layer and you check. If the destination is myself, I pass to UDP TCP layer until you pass to layer 7, which is software layer. Sorry, layer 7. So that's why the answer from that student say, yes, we should have IP, because if no IP, this guy may drop everything, right? Because it's not belong to me. I don't have any IP here. Let's have a look. Okay. I make a bigger computer here. Oh, sorry, not that too big. So what's happening is hub send your traffic, and from the concept, you have layer 2, layer 3, top layer. And Wireshark is on top, right? Wireshark. From that student say we must have IP. Okay, 10.0.0.3. So in that case, the traffic will pass through these layers. But remember, when I get this copy from hub, and remember this traffic is source A, destination B. Forget about layer 2. And when you match your destination, because this traffic is destination B, and for my computer's destination is C. So B is not matched with C. If we follow this rule, we will drop this traffic here, because the destination is 10.0.0.2 and myself is 3. I'm not going to forward this traffic to upper layer because this does not belong to me. So that's why back to here, we have this called the promiscuous mode. What's happening is the real world, what's happening here is Wireshark will enable promiscuous mode on your NIC. And promiscuous mode will do is, see the definition here is a present all the traffic destination. When you say regardless of the destination, it's about layer 2 destination, layer 3 destination. That means if I run promiscuous mode by Wireshark on this computer, when I receive this traffic, even layer 2 destination is not me, I'm okay, pass it, pass. Even the destination is .2 and myself is .3, I don't care, go pass, pass. And they will pass to the workstation. Sorry, not workstation, they will pass to Wireshark, capture it. So in that case, really we don't care if I need to have IP or not, right? Even no IP, and your interface running on promiscuous mode, it's like you remove all the filter, you start listening everybody's talk without the filter on your side, which we call promiscuous mode. So without IP, that's fine. You can start listening. The only thing is, if you don't have IP, you cannot talking to the outside. Means you cannot talk to A or B because you don't have IP. But nobody can stop you to listening this, because if you run promiscuous mode, you can listen the entire traffic inside the hub. Okay, so that's why now nobody use hub. Like I said, there's no security, means you can listening everybody's talking. Now everybody use switch. Okay. And now the question back here say, okay, if everybody runs switch, how can I use Wireshark? So if you buy the switch from different company, they have a different name. Some guy will say listening port. Listening port is you define one port. I say from this port, I want to listen to another port traffic. So normally this is admin. Administrator will do this job. So administrator will keep here and keep monitoring the traffic from the certain VLAN or certain physical port to do troubleshooting. But that's for the physical switch. For the virtual switch, what can we do? We can enable this promiscuous mode. If we turn on this mode on, what's happening? You immediately turn this switch become a hub. That means whatever A talk to B, C can listening. Whatever A talk to C, B can listening. Okay, so when you enable promiscuous mode, you turn the virtual switch become a virtual hub. Means you lower your security. And the reason for that is maybe you have a VM dedicated for Wireshark, and you want to check what's happening inside the switch or what's happening inside my network. Okay, so you can enable promiscuous mode, but remember when you finish your job, turn it back. Okay, so this is a promiscuous mode. So just remember, if you have a PC running Wireshark, and if you just want to lessen what's happening inside this network, not talking, just listening, no IP needed. If you put the IP, not harmful, but the basic rule is you don't need to have it. Okay, you want to keep yourself invisible from other people, and you just want to listen what's happening here. Okay, so you don't need to put IP there. Okay, so this is a promiscuous mode. Give you an example. If you later, because this one you may need it. Okay, go here. So I can go CCIE version 5. I need topology. Okay, let's pick up this one. So later when you do your technical or architecture lab, you may find I designed this routing lab, which I call the CSR pod. So this is based on this topology. Okay, forget about the right hand side. It's everything's on left hand side. You have your router, and we have one Wireshark, and this line means there's a switch. So if I want this Wireshark capture the traffic between router 1 and router 2, I cannot keep this as a switch, right? I need to turn this one become a hub. So in that configuration, if you have a Wireshark running, you should turn the promiscuous mode on. So in that case, you can lessen all the traffic between all the routers on Wireshark. Okay, so that's why sometimes we need to have this promiscuous mode now. Even we don't have that high level security built in for Wireshark, this is you must have. Okay.
Sorry, Dajan, but in the practical scenario, I think this would impact the performance because
yes,
yeah.
I agree. Yes, this also impact the performance. It's not about virtual switch in the. Just think about this. In a physical switch, first thing I have two. Okay, for the physical switch, I have one interface, two interface, PC here, PC here. And before adding a Wireshark PC, what's happening? Traffic get in, and this guy checking the MAC table, send out, right? Just one package sends through the entire switch, which we call switching, like your circuit board. If we add a listening port, the CPU need to make a copy and send to the other guy, which is listen this port, right? So we're actually adding a lot of CPU performance. This adding a CPU load. That's one thing. Second thing, because you add more traffic, you have double the traffic, right? You double the traffic means you have much loader, heavy loader for heavy load for your switch. Same as this virtual switch here. Let's say I have still three PC. Maybe one more PC here. Think about if they talk this way, and now this switch need to make all this traffic a copy, sent to all the port, right? Let's say if I have one talk from this one to this one, I need to make another copy sent to here. I need to make another copy sent to here. So at the same time, you have a talk between these two. I need to make a copy sent to here, make a copy sent to here. So in that case, you know, this student is right. You add a lot of CPU CPU load, and you lower the performance of your switching because now it's become a hub. There's another reason we gave up this hub because of performance, right? One package you talk to everybody, really, you don't need to have that. Also, you impact all the client because client will receive, let's say 100 traffic and maybe 90 of them not belong to you, not yours. Only 10 belong to you, but actually all 100 traffic sent to everybody. So In the production, yes, promiscuous mode just for short use, like troubleshooting. After that, turn it back. Okay, just don't keep it on. Okay, so this is about promiscuous mode. Next two are very easy to understand. One is called MAC address change. Accept or reject the inbound traffic when the MAC address has been turned by the guest. Second one is for transmission, accept or reject outbound traffic when the MAC address has been changed. So what is this two feature talking about here? These two feature actually is one is called inbound, one is called outbound, but they gave a different name. What's happening here is if you have a virtual switch and I build one VM and gave to one of the company, let's say this belong to company A. I build another VM and this will belong to company B. So myself will be company C. I'm the system manager. So if you turn this both feature on means if I have by default, if this MAC address is 1122.3344, and my virtual switch will have the record for this MAC address. Okay, so if customer A starts saying, oh, I want to play with my computer's MAC, some software can override the traffic MAC address. This guy say, I want to put something different. Let's say this guy put 1234. If you the secure feature on, the switch will reject all the traffic because they say, this is not what I signed to you. This is something you played or you changed. So I'm not going to accept it. So this is kind of outbound. Inbound is same. If from outside, someone change this MAC address, play the trick. Traffic. So it's kind of inbound, outbound. So this is only happening is you have your company manage the virtual environment and you have other customer which out of your control. They have their own virtual machine inside. So this is like making the rules that don't play with the MAC address. For example, if you allow them, A may say, okay, I want to put 3344 here. And if both in the same switch, your switch will be say, I have a duplicate MAC address here, right? So that will cause some issue. So that's why we have these two features to just control the MAC address. Just say, don't play with the MAC address. It's not allowed. But if you own the entire environment, like you are system administrator for your company and your company don't give the service to the other company, you can keep the both option off, right? So because you control everything. Okay, next one is traffic shaping policy. Network traffic shaping is a mechanism for limited virtual machines consumption of available network bandwidth. Yeah, kind of the bandwidth filter. They have a few parameters. One called average rate, another one called peak rate, and the bus size. Okay, so let's see. Yeah, they have the configuration. So string number. It's very easy to understand. First thing you said, they already put here. This is your average. Okay, that means for daily use, your user not allowed to go over this boundary. Means you can put a number. And for the peak bandwidth means for the short period of the time, you allow user to have a higher bandwidth. Okay, but not for this, not this forever, right? That's why you have the third is called bus size, and you may say this is the entire data you can transmit. Okay, after that, I'm going to lower your bandwidth back to normal. Okay, so this is kind of the three parameter here. We have some parameter here. So I remember a long time ago, like almost 14 years ago, I was using a one ISP, which if you are from Vancouver or Toronto, you know this Shaw cable. Okay. Because that's a long time ago, not everybody has a high bandwidth, not like today, everybody get 1 gig. Right, ISP only provide you 10 meg maybe 10 meg download for the average, and cost you, let's say, still, in Canada they cost you a lot of money, $70 per month. And they also add some features that if you want to add $5 a month, I give you some features as same as this. For the short of the time, normally they say for 60 seconds, I allow you use 30 meg for 60 seconds. After that, your price will drop back to 10. And the cooling down time, this cooling down time may be 15 minutes. So after 15 minutes, if you still need a high bandwidth, I give you another 1 minute for this high bandwidth. Okay. The same idea as this, but they turn it become a business model to ask you pay some extra money to get some extra bandwidth. For me, I think this is good because if you because I run firewall in my home, right? So I use Bell in Halifax. So Bell has a few options. You have 100 meg down, 1000 meg down, and 1500. I think 1 point. Sorry, it's 1. Yeah, 1.5. What says meg down? 1.5 gig. 1.5 gig. This is 1 gig and 100. And you see, this is how they do the business, right? Between 100 and 1 gig, they don't have anything like 2, 3, 4, 500. I use this 100 because first thing, this is the cheapest plan I have. And second thing is because I run firewall at my home, and you can see if this one is 100. For my daily traffic, the daily traffic is around here. Maybe during the evening, my son, daughter come back, watch YouTube, the traffic go a little bit higher, something like this. If I start downloading some big data, they go 100. Finish downloading, come back. So in that case, the only impact for me is when I'm downloading the big document or files, this one may limit my bandwidth, but this one only for, let's say, 2 minutes or 5 minutes. So it's acceptable. If I have a higher bandwidth, I save from 5 minutes to 1 minute. But actually in the day, I only download 1 or twice. So I won't save a lot of money. I won't save a lot of time here. But when you pick up this 100, you save some money. Okay, so that's why if you're a technical person, you know what you need. And it's much easier for you to choose which bandwidth you have. But if you call this, this interesting thing is if you call the bell, said, I need to have a brand new internet installed, normally they ask you, how many people inside your house or apartment? You may say, oh, we have a 4 student shared apartment. And this guy will say, oh, you have a 4 student with a 4 laptop. You definitely need to have this highest speed because this guy will say, oh, you may feel slow about this 100. But the truth is, if you run traffic analyzer, you will find you really don't have more than 100. So another reason I say that is because I manage the entire our department network, right? I have my firewall. We have a firewall there. So before, like 1 year ago, they just upgraded from 100 meg to 1 gig for the entire department. So before that, in the past 10 years, it's always 100. 100 meg for what? For all the office, which means everybody's office, include Dr. Robson and Shirley's office. 3 lab room. 3 lab room is around, we have 40 PC plus 35 plus 25. 100. And plus I run almost 500 virtual machine. Plus. Okay, for that 100 meg traffic, I'll run, let's say, 700 PC at the same time. and nobody complain, right? Someone still watch YouTube, someone still doing their office business, and nobody complain about this 100 Mac. So the thing is telling you is just when you buy something, just do the research before you buy it, because for me, I believe 100 is more than enough. Okay, so if you want to prove it, you can run your own Wireshark. Sorry, not Wireshark, the firewall, and just try to analyze the traffic. Okay, so this is about this part. This is how you're going to configure. You can turn it on and just put some parameter here. Okay, and you can have this traffic shape. For the VM, back to here. For the VM, why we need to have the traffic shape is, let's quickly go. If we don't use that one, if I have a VM, the only thing I can control is this virtual NIC card, right? The virtual NIC card will be 100 or 1 gig. They don't have 100 anymore. Okay, 1 gig or 10 gig. So if you assign the 1 gig virtual NIC to the VM, if you don't put any limitation, the VM can use the entire 1 gig. Okay, so that's why if you have lots of VM connect to one switch and they only get 1 GB out, you may want to put some limitation here, say 150, maybe 200, something like that. Okay, if you don't put, maybe the first VM will use the entire 1000 and there's nothing left for the rest of the VMs. Okay, next one is NIC teaming. So the NIC teaming and forward policy by configure specific options. Like I said, standard switch has a basic teaming, the static teaming, not dynamic one. If you want to have a dynamic one, you need to pay the money, get a distribute switch. Okay.
Sorry to interrupt. Is it this is just like bonding, right?
Yeah, this is a bonding, but when you do teaming, you have different policy, right? The default one is I configure my side, you configure your side. And if we are matched, the traffic goes through. Dynamic one is they start negotiate the parameter between source and destination. They can negotiate and make sure everything is okay. So static one is really the basic one, and the standard switch only supports the basic one.
Okay.
If you want the dynamic one, which they can negotiate between virtual switch and the physical switch running the protocol, you need to pay the money and get the distribute switch.
Okay.
Okay. Normally here is you have a VM NIC. It's around here or around here or around here. If you put this, you can move this NIC to here, or you can move this NIC to here. If you move the NIC to the bottom, means I don't need this interface for this switch. Maybe it's for the other switch, but not for this switch. If you put on a standby, that means the first interface, if the first interface down, the second interface will be active, become active and taking care of the traffic, which we call the active backup. If you put both NIC here, they become active. And just make sure if this guy going to a physical switch, make sure you configure these two interface as a static bonding. Okay. Next one. Next 3 PowerPoints are talking about load balancing. Okay, let's have a look. They have different way to do load balancing. The first way we say originating virtual port ID. So the diagram shows the routing based on the originator port ID called virtual port ID load balancing. And next one is source MAC hash. And next one is source destination IP hash. Okay. First one. This is all this VM will provide the service to the outside, like browser, like the HTTP server. They all provide traffic to the outside world, and this all a client here. Okay, this all the server. So how they do the load balancing? the first thing, all the traffic will send to one virtual switch. This virtual switch has 3 physical outgoing interface. So how this switch make a decision said which interface, which traffic should go which interface. Normally they go this way. So if this is number 1, this is number 2, this is a number 3, this is number 4. This switch will say, okay, number 1 go to first interface, second one go to the second interface, third one go to the third interface, and the fourth one go back to the first interface. Okay. So after that, you send to the outside. Outside world is the real world, means the switch will send the traffic to destination, which is their job. But inside, this teaming is like 1 map to 1, 2 map to 2, 3 map to 3 map to 3, and 4 go back map to port 1. Okay, so they bound this NIC interface. This is a NIC ID 0, 1, 2. Okay, they have the 1-to-1 mapping. Okay, number 4 map to here. So this one called based on virtual port ID. Okay. So this one is not dynamic run, right? If I have, let's say, it may have some issue with say, this is a dynamic map, this is a dynamic map, this is dynamic, sorry, not dynamic. It's like kind of 1-to-1 map. And in that case, this guy only go here. So in this case, there's no traffic goes through this card because this 1-to-1 map may cause all the VM send through one interface and other interface is empty. Nobody use it. But this is with less CPU impact because CPU don't need to make any decision anymore, right? They have the table said PC1 map to 0, PC2 map to 0, PC3 map to 1. Simple mapping, and CPU don't need to involve this load balance. Okay, next one is called the source MAC hash. Before this one is because the virtual switch has this port group here. So they map the port group with outgoing NIC card, right? Doesn't matter about this VM, it's a MAC, right? We don't care the MAC address here. Next one is about the MAC address. So I don't care the port ID anymore. Now I care is the MAC, the source MAC, because this is my server, this is my client. So I do the source MAC hash. You know, when you do the hash based on the MAC address, you will get a number. Maybe it's 0, maybe it's 1, maybe it's 2. Right? So because the first 2 guy may have the similar MAC address. So maybe after hash, all this MAC address will send through one interface. And this will hash and through another interface. And in that case, there's nobody use this. Okay. So that's why I say in that case, this guy need a little bit CPU load because CPU will calculate this MAC address from the hash. This one may get a number say 0. This MAC after calculate, you may get this hash is number 1. Okay, so this one need a little bit of CPU involved. So the best one is called source and destination IP hash. So instead of your source MAC, now you do the IP. So the best thing is if I have one IP, server IP, because my source IP, my top one, and if I hash let me get 1. So in that case, even with this hash, so you get totally different results. So the first guy may send through the first traffic interface. do and send to different customer. And because this is different IP, when you do IP source destination IP hashing, this guy may go from second interface. Okay, question? Okay, so this is a source destination IP hash, and you will see here, this need a lot of CPU working on this, because if I have a new client PC join, a new client will have a new IP, and the CPU will do the hash between this new destination IP and do the new hash. Maybe this is 1, and this traffic may go send through this way. Okay, so everything will have like a double. It's a double. What's it say? When you add some new feature, you also need to consider the CPU impact, because all the feature you add on, you increase the load of your CPU. So it's based on the environment. Sometimes it's not say source destination IP hash is the best. It's based on the environment. Maybe you have a simple environment. Maybe this virtual port ID is the best environment for your design, okay, or scenario. Next one. So the VM kernel can use link, states, or beacon, or both to detect a network failure. So network failure is detected by VM kernel. VM kernel is ESXi kernel. It's the same idea. So which monitor the link state and perform the beacon probing. So VM kernel notifies physical switch of the changing in the physical location of the MAC address forward immediately by VM kernel based on the configuration. You have forward. Forward means let's see how the physical adapter is returned to active and due to after and load balancing. Forward means you have active backup, right? If active lost a connection, backup become active. Load balancing is active. If you active, if you lost one, all the traffic you send to the second port. Okay, so it's a two-way to do the forward. Here it says always use a VMNIC uplink as the top of the active adapter list. If you remember, if you have active, you have the list. This one is always number 1. If we lost this guy, second one will take care of the traffic. But when the first one get back, all the traffic will shifting back to the active one. Okay. Lab 7 is use standard switch. Okay, next part. So next part we are going to talk about is the distributed switch. Distributed switch enhance the user for physical NIC with a speed of 10 gig. That's the old one. I think the version 7, even standard switch, you can use 10 gig physical NIC card. Okay. Benefits for the distributed switch. Benefit for distributed switch over standard switch is simplified data center administration. Provides support for advanced feature like private VLAN, NetFlow, port mirroring. Instead of you see a promiscuous mode, turn it to the hub. Now you can say dedicated port, I want to monitoring your traffic. Okay. Enable network status and policies to migrate with virtual machine during the migration of vMotion. Provide the customized third-party development. Okay, go back here. How to understand is simplified data center administration. Okay. Without the vCenter, so means without vCenter means we cannot use distributed switch. So what's the issue here? If I have 3 ESXi in my company, And today your boss said, I need to have a new VM belong to new network doing testing. Okay, so you say, okay, I'm going to build a VM. Not big issue. I know how to build it. I need to build a new switch. Oh, no, I put on top here. New switch means like switch 5. You need to give a name. Okay, you say test. And you build it, it's running. So next one, your boss say, okay, I want to make this VM become a little bit high availability. Means if I lost this ESXi, I want this VM immediately boot up in the next available ESXi. You say, okay, ESXi can, I can take care of that, or the ESXi will take care of that, no problem. But the issue here is move the VM is very easy. One click, you move the VM. The hardest part is the network. When they move this VM to the second ESXi, and this VM will say, I'm looking for a network which name test. And this ESXi say, okay, I don't have this network. So that means this VM cannot power up. No power up because this VM cannot find the network. What's his solution? You may say, okay, if this guy looking for the network, I'm going to build it. I'm going to put a test. And VM may check, say, oh, this test, it looks like not my test because this is a capital E. Okay, so you say, okay, sorry, mistake. I should follow that. Sometimes, they put 1. UVM may say, oh, this is not the same as the test. I don't like it. I need to edit it. So in that case, you need to 100% sure all these parameter identical, name, everything identical. That's only for 2. Your company has 3. Now you go log into another guy, build another test, and think about that. If you have 100 of this machine, you don't want to do this 100 times, right? Because maybe you put something capital T, or you spelling wrong become TETS, whatever. This may all cause an issue, and you won't find it until someday this VM moved to this and ESXi and couldn't put power up. And the worst case is after a few days, your boss said, I don't need this virtual machine and the network. Please go ahead and delete it. What you can do? Delete VM, just one click. And log into each of these ESXi, delete the network will be a nightmare for you, right? So that's why we say less smaller environment, that's fine. 3, 5 hosts, no problem. 100 hosts, forget about it. I cannot do this way. So that's why they have this distributed switch. If I'm the system manager, I have my vCenter, I will say, please build one distributed switch for me, name test, if I have my VM here. And vCenter will send a command to all this ESXi. I say, okay, let's build it. They will build one huge switch across the entire ESXi and say, this is your test. And done, that's all. So now the VM go here or move to the next guy or move to whatever ESXi. Everybody has the same switch inside this data center. Okay. Any question?
So this distribution is just about the copying the configuration into all machines, not about the cooperation between different devices.
Yes, like standard switch, you need to go each of the ESXi configured. Now you just send one command, they will build one switch across the entire data center. That means all the ESXi has part of this switch.
Because I was thinking that this distribution means that, for example, in ESXi1, we had one VMware which want to communicate with VM2 in ESXi-N. So we have to have the distribution.
Okay, I got your question there.
Yeah.
Okay, your question is like this way. Let me draw this. Good question. Good question. Let's say I have VM1 here, I have VM2 here, and from here I have a physical switch connect to ESXi. And I believe you're asking is if I want VM1 talk to VM2, which belong to two different ESXi, so should I use distributed switch or I can use a standard switch? Okay, the answer is like this way. If we said, let's say let's say don't make it so complicated. Let me make a switch here. Let's say this is my switch called test. And test just like this VM1 talk to test, talk to this guy, talk to the outside world. And if there's no VLAN tag, I say this guy's IP is 10.0.0.1/24. And this guy talk to the outside world. And I say this is another part. So traffic sent to this ESXi, you can have another switch which you can name test ABC. And this traffic actually will pass through this test ABC and send to VM2 if this IP is 10.0.0.2/24. Okay, so VM1 can talk to VM2. Whatever you put on under doesn't matter. You just make sure your layer 3 can talk through the entire network. Even you say if this is across the internet between two different locations, that's also fine. You just treat this topology as one computer goes through internet, goes through another computer. If they have good IP, if they have a good connectivity, means all the virtual layer, physical layer, okay. Two PC can talk to each other. So you don't have identical switch. And you can even put a VLAN here. You say VLAN 10. I may put this guy as VLAN 10. This guy may put VLAN 20 if you put access one, like the interview question, right? VLAN 20, VLAN 20. Yeah, both can talk to each other. So you don't have just make sure your layer 3 can reach from source destination. You really don't care about what is your layer 2 or layer 1. And you may say, okay, if this is okay, why we need to have this distributed switch or standard switch have the identical name? The issue is if this is your company and one day your boss said, please move VM1 close to VM2. vMotion can do that. One click, VM1 fly to this ESXi. And VM1 will say, where's my network? This guy has test ABC, but I'm looking for test. In that case, you may say, okay, I'm going to put a test and I may try to connect these two together. Or you may say, you may manually go this VM and say, okay, now you forget about your test. Now you are going to join test ABC. So if you have the manually involved with clicking, say, replace the name, there's no automation. Your VM will keep down until you go and click. So what happened? We want automate boot up, right? If something wrong here, this guy move and boot up. So that's why we want to keep the same network with the same name across the entire infrastructure. So standard switch will do this, but like I said, it's for small amount ESXi, that's fine. But when you have more, you better use the distributed switch. So distributed switch just cross the entire network. Yeah, first thing you're right, you will provide the connectivity between all the VM belong to this network. So it's based on what? It's based on everybody has the same configuration, same name, same VLANs, everything's the same. So if you have everything same on layer 2, layer 1, you're definitely okay with your top layer, right? So this is just simplify your configuration job, right? So concept are the same. Is that clear?
Yes, thank you. Yeah, I got my.
Yeah, this is just it's not about like I said, back to the company. It's not about technology. It's about how this company can making more money. You know, you need this feature. You need to pay a lot of money to have this feature, right? They don't give you for free, so that's why based on your company size, you pick up the right feature for yourself for the company. Okay, let's compare with the features. See, NIC teaming. Both standard switch and distributed switch support NIC teaming here. And only thing different is if you want to do the traffic shaping, outbound traffic shaping, standard switch supported. If you want more feature, like a VM network port block, private VLAN, load-based teaming, this all have the feature on the distributed switch. Okay. Next one. Oh, this one is back to that concept. So this is a distributed switch architecture. So what's happening here? The first thing, you have the bottom two server. And in each server, you have 3 physical NIC, right? And forget about this part. So at the same time, in your vCenter, now you give a command said, oh, this already vCenter here. The vCenter gave a command say, okay, build one distributed switch for me. And distributed switch will cross the entire infrastructure like this way. But actually, there's no way you can build something cross the entire, right? Because they are physical in a box. So what's happening is the vCenter actually will build something like this virtual, which we call the hidden virtual switch, which we won't see it. They will do physical mapping, the uplink port to the physical port. And they will present this port to this distributed switch. Okay, so now for the physical layer, whatever internet on the bottom, now this traffic can go to the distributed switch. So on the top, now you can build the port number, the distributed port groups, right? This all the port groups facing to the VM. And you can also move the switch to the distributed switch. And you can also move your vMotion port from standard switch to distributed switch. Okay, so that means you can, at this moment, you can shut down your standard switch or delete the standard switch and move everything to the distributed switch. Okay, this is example. Distributed switch example. You create a distributed switch named VDS number 1, and you create a port group on the production. Okay, first thing, you are going to build this distributed switch with a name. Okay, name is VDS number 01. And after that, you are going to create a port group named production. Okay, that part is production, which will be used for the virtual machine networking facing to the VM. And you also assign the uplink VM NIC 1 from host 0 and VM NIC 1 from host number 2 to this distributed switch. Okay, so that means I can have another distributed switch and I can map this two interface here. I can have another distributed switch which I can map this to the card here. So you can have a multiple distributed switch inside your vCenter. Okay, so this is how you're going to view it. It's under the same networking tab, and you can go see. Now the first one is DVS, distributed virtual switch. Next one is how you're going to create the distributed switch. You click add, you click a new distributed switch, and you give a name for that switch, and you put how many uplink port you want to have, and what is the port group name. You may say production, whatever. And you can put a different MTU size. By default is 1500. And you can have a multicast filtering here. You can have some basic or whatever. And the Discover protocol, you can have a CDP, which is Cisco Discover protocol. You can find your neighbor CDP protocol. migrating network adapter to a distributed switch. After you build a switch, VDS. So before you build VDS, you definitely have some standard switch already running. So during your configuration, they will ask you, say, do you want to migrate your management, or you want to migrate your any interface you want to move from here to the virtual distributed switch or VDS. If you follow the lab or manual, you will say, okay, just move some VM port from my standard switch to distributed switch. After that, I have my VDS, and I already have the port facing to the VM. So the issue now is, where's my bottom interface, which facing to the internet? That's why you start sign this VM NIC. You may say this is a VM NIC 3. Please please go to this virtual distributed switch. Okay, you can manually sign the uplink from next step. After that, you can go to your virtual machine and say, now you are not going to talk to my standard switch. You can go to talk to my distributed switch. So you can go from the list and pick up different network. Editing distribute port group general properties, you can just go edit settings and have some basic and VLANs, all these features there. These are all the features. You can allow or disable them about VM kernel network level. What's that? We are still back to VM kernel. VM kernel back here again. They provide management interface, vMotion, storage, high availability, tolerance, fault tolerance. All the features just go through the kernel. Okay. This is how you are going to move, or you are going to create the VM kernel adapter inside this distributed switch. Okay, some problem and analyze. So network consideration. Okay, let's have a look here. Your virtual network environment realize a physical network has number of physical switches. This is fine. This is what I'm talking about. It's 802.3 AD. This is a protocol doing the teaming, which is called dynamic teaming protocol. Okay, means all this virtual switch and the physical switch can talk to each other, or physical switch to physical switch can talk to each other. This is only available for distributed switch. Okay, if you have a standard switch, this is not available for you. Okay, so they also support .1Q trunking protocol. LACP is a link aggregation control protocol. I think this is a dynamic one, sorry. LACP is a teaming protocol. Link layer LLDP, which is a third party. And if you have a Cisco equipment running with your VM, you can use CDP. If you have a HP, Huawei, LLDP, it's their protocol. Okay. Lab 8 is use a distributed switch. Okay. Okay, so we're done with that part, and now it's 11:49. Okay. Let's finish a short talk, and we will have our lunch. So what you learn here is that you compare a standard switch with distributed switch. You will say, oh, distributed switch has more features, all this extra feature. It's good for your customer, also good for yourself for the management. But there's an issue here. In the real world, I cannot say 100% sure. If you get a chance to visit the real VM environment, you may find this way. We use distributed switch a lot, but we didn't give up the standard switch. You may say, why we keep the standard switch? What does standard switch do? I still keep my standard switch for what? For this, for the management, for the iSCSI, for the vMotion, for everything. I may have multiple switch for dedicated job. If you remember the standard switch, one dedicated port on the one dedicated switch for vMotion, one dedicated port for iSCSI, and distribute switch only facing to VM. I don't use distribute switch to do the management. And you may say, what's the reason behind that? Looks like distribute switch has more feature there. Okay, the reason is if everything's running, there's no issue. So when something getting wrong, this become a big issue here. Let's say if I rely on distribute switch. Yeah, sure, no problem. Okay, so don't worry, just take care of yourself. Okay. Okay, back to here. So what's the real scenario here is if I'm here, I log into vCenter, I config, login config. After that, I config everything here. So if my vCenter gets some issue, I cannot config my distribute switch. And because my management interface is bonding with distribute switch, there's no way I can log into my ESXi and troubleshoot because it looks like everything's locked out. But the issue is if I cannot log into one of the ESXi, maybe my vCenter VM is here. If I cannot log into this ESXi, I cannot log into my vCenter or I cannot configure my vCenter. If I cannot configure my vCenter, I cannot configure my distributed switch. So it's become a dead loop. Right? Because your vCenter down, you cannot configure. You lost a distributed switch, so you cannot get inside your ESXi, which you cannot fix your vCenter, and it's a dead loop. That's why we said, because if you really do some lab, doing that, you will find it's very easy. You do something wrong and you immediately block the entire system, and there's a dead loop. You cannot fix anything. That's why we put standard switch here. And at least I put the management MGMT. And if I can do more, I put iSCSI here. So if my vCenter down, I still can log in my dedicated ESXi through my management interface. So if this vCenter is inside, I can troubleshoot it, or I can just build another vCenter to replace this old one. So I have a lot of ways to fix the entire system. So that's why in your book, they said you can do this, but in the production, I will say, if you can, keep your management to the simple, easy, reliable standard switch. If something really getting wrong, you'll still have a chance to save the system. Okay. So this is about a distributed switch. Sometimes don't follow the textbook, because if you follow it later, you may have a bigger issue here. Right. So back to these days, we talk about a lot about this Facebook issue. The Facebook has a DNS issue I already taught yesterday. So this is kind of design issue. They said it's okay to rely on DNS for 90% of your traffic, right? Your routing, your whatever, but you should have the outbound management traffic, right? Outbound, let's see what's the full name for this. Oh. I think they called another short name of this OOB. Okay, out of this one's called out of band management. Okay. Next time when people talk about OOB, at least you know what is this. Okay. Out of band management. So now this is not about VM, it's about when you design something, make it reliable. The people said the most case here is Facebook's communication system also inbound. Inbound means if this is the traffic, the production network, testing network, everything will go through this inbound traffic. The outbound traffic may say you have a tiny small bandwidth or network. They only taking care of the traffic. They only take care of the management like SSH, config router, communication. And because this door locking system is also inbound, so that's why people even cannot open the data center physical door to get inside, right? That's why they find the saw to cut this door, cut the door. So that's why when you design this, we always say you have outbound, the OOB here, and you put a critical critical system to the OOB. For example, they said if I have a router and this router run BGP, normally the BGP has an interface going all the internet, and all this internet traffic, we said this is inbound traffic because that's your production traffic, everything. And they said don't put your management also goes through this inbound traffic. Okay, put another small network just dedicated for management. So if I'm the system administrator, I can easily log in and I can easily manage this. Even the entire traffic system are down, no problem. I still have my OOB here, so out of band management. So I can easily recover or roll back the traffic, roll back the configuration and bring everything back. So they said this Facebook issue is they put everything inbound. That means if something wrong, you bring the entire network down. There's no way you can recover it. Okay. So this is same idea everywhere. If you check what we have inside our internet working, let's say if I have my switch, you have another switch, I have another switch, you have my firewall, you have my storage. And you will see all this guy connect to a big Cisco Nexus switch, let's say N3K. Okay, everybody is connected to this switch. And this guy connect to the outside world internet. And this side may connect to your lab room. Okay, so what we call this is a inbound of the configuration, means all the traffic, 99% of the data traffic goes through this goes through this network. But as myself, I have another small switch. It's a Cisco, even you don't need a gig switch, 100 meg switch is okay. And for all the equipment, they have a dedicated management switch interface. So you can run the RJ45 to that switch. And even this N3K. So I can log in from this switch to all this one. Even the entire network down, lab room has issue, even the core switch has some issue. I still can log in from the dedicated switch and get from the management interface. Okay. So this is something you will considering when you go to the network design job or system administrator job. If you don't consider this well, like if I don't do this part, right? If I don't do this part, what I can do here, I can say everybody has an IP, management IP, everybody goes through the same terminal, talk to switch, and the switch talk to firewall, and I can log in from firewall VPN, go through switch and go to my firewall here. That's storage. But the issue is if something wrong with this switch, I don't have any chance to log in and configure it. So only out. And hopefully I can open the door with my swapping card and go there, physically connect a laptop to the console port and roll back that command, which I gave maybe wrong or whatever. Right, so this is in the same city. Some other case, you are not in the same city, right? You are system administrator maybe in Toronto, your office is in Halifax. You don't want to pay some guy fly to Halifax and just put 2 commands and get back, right? So that's why when you design the network, always thinking this OOB here. Okay. Always think about this OOB. Yeah, out of band management. Yeah, not this one. Okay, so this is for the morning talk. So 12 o'clock. So let's have a lunch break, and afternoon will start 1 p.m. Okay. So if you have any question, just let me know. Okay, so if no question, you can leave the meeting. So I will see you this afternoon. Late is okay, don't worry. How late you can? Half hour? Yeah, so yeah, okay, 1:30, sure, no problem, just join. So if you come late and you say something you don't understand, I will repeat my talk again, don't worry, okay? Okay, good. See you this afternoon, guys, girls.